Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, let us solve question number 1 of JEE Advanced 2014. At time t equals to 0, terminals A in the circuit shown in figure, this is a A, is connected to B by a key and an alternating current IT, which is I naught cos omega t. So this is the alternating current that is given here, I naught cos omega t, with I naught is 1 ampere. So the maximum current is 1 ampere and omega is the angular frequency, we say, that is 500 radian per second. Starts flowing in it with the initial direction shown in figure. So the current is in this direction actually, starting with clockwise direction. At time t equals to 2.7 pi by 6 omega, the key is switched from B to D here. So from the switch is now changed from here to here. Now onwards only A and D are connected. So we have got two cases, that once this is connected, this circuit is complete, another time is this part of the circuit is complete and this is disconnected. So two diagrams we have to make. A total charge Q flows from the battery to charge the capacitor. So when this is connected to this, the charge will flow from the battery to charge the capacitor fully. If C equals to this and R is this, so C and R values are given, and the battery is idle with EMF 50 volts, so it is not having any internal resistance. Identify the correct statements. Statement or statements. It is more than one option correct. It can be any one of the four or it can be more than one. The first is talking about magnitude of the maximum charge on the capacitor. The magnitude of the maximum charge on the capacitor before t equals to this is this. So that means you have to allow the time to flow from 0 to this much time and see within that time what is the maximum charge on the capacitor. So to solve this, let us first draw the first diagram. There is a alternating current which is provided to the capacitor. This is the capacitor, which is having capacitance 20 microfarad. 20 microfarad capacitor. The current that is given is alternating in nature, and that is I naught cos of omega t. So initially the current direction is given, that is clockwise. So initially the current is in this direction. If the current is in this direction, then this will be positive and this will be negative. This will be negative. Initially this is in this direction. So initially, as the current is in this direction, we know that if I have a battery connected to a capacitor, the current is in this direction. Suppose that this is positively charged and this is negatively charged. So this becomes positive and this becomes negative, and you can see that initially at time t equals to 0, current is maximum. I naught starts with maximum current and it will gradually decrease. It will follow this curve, cosine curve. This is how it will be. Now this is the time I am taking in x-axis, and it is the current in the this is the graph of this one I am drawing here. cosine call. Now it is the maximum at time t equals to 0, which is I naught obviously. So the current is decreasing, but it is positive, so it is during this time it is positive. After this much of time, it will reverse its direction. The current will be in this direction. After this time, it will be in that direction. So after what time? After 1/4 of the total time, that is pi by 2 omega, 0.5 pi by omega. Then after that it will be in anti-clockwise and attain a maximum current in this direction, negative here. So current is maximum. Then it will start decreasing, but in the negative sense. In the same sense, it is moving. So our concern is the time that is given is 7 pi by 6 omega. Where that time will lie? This total time I'll write 2 pi by omega. So this one is 1/4 of that. So this is actually pi by 2 omega. So it is 0.5 pi by omega. This one, and this is a little more than 1. And here it is. This is actually pi by omega. And this time, the constant time, where it is somewhere here. Suppose this is 7 pi by 6 omega. So our constant time is this one. So during that time, the current was in anti-clockwise sense. So the current will keep on in that sense. That means this will be positive and this will be negative. So by the time when the time is 7 pi upon 6 omega, the current is in anti-clockwise sense and the lower plate is positive and the higher plate is negative. Now the higher plate is negative, so magnitude of the maximum charge on the capacitor before this. So to find the charge, maximum charge, because you can see that the maximum charge is up to here, okay, because this is positive and this is negative, this will cancel. So the maximum charge is attended here. So this is the area under the curve. Here the charge is maximum at this point, and that can be obtained by 0 to this much of time. So first of all, let us write the equation for the charge. And what is the charge during this time? So total charge during this time, before this time, up to this time, then I will find the total charge under this curve. But this is the maximum, but total charge up to this time is area under this curve. So let us move to that. But because we have the equation I equals to, this is a function of time, I naught cos of omega t. This is the instantaneous current that is flowing in the circuit, and I naught is, I write that is dq over dt. The current is the rate of flow of charge. It is I naught cos of omega t. So from here dq is I naught cos omega t dt. If I integrate this from the constant q as a function of time is given by integration, our constant time q as a function of time is equal to integration of this value I naught cos omega t dt, and it is 0 to any time t you want. Starting with, we want this time 0 to 7 pi over 6 omega and see how much I'm getting. So from here I'll just write one more step here. Q is that much of time that I'm going to put here. I naught is there, that comes out. Cos omega t integration is divided by omega and sin omega t dt, sin omega t, and that varies from 0 to 7 pi by 6 omega. This one. Okay, that is I naught by omega, and 7 pi by 6 omega I'll put here. Omega into t is 7 pi over 6 omega minus 0. This is I naught by omega. This omega, that omega will cancel. 7 pi by 6 sine of 7 pi divided by 6. If I find that, then how much charge is actually stored during the time 7 pi by 6 omega? Okay. So how much charge is stored during this time from 0 to 7 pi by 6 omega? This I have to solve. And 7 pi by 6, I'll write this as 2 pi plus pi by 3, pi by 6, pi plus pi by 6. This is sine of pi plus pi by 6, and that is sine pi plus theta is minus sine pi by 6. This is minus half. If I put that, I naught omega, minus is there, and this is 1 by 2. If I put these values, and I naught is 1 ampere maximum given here in the question, and omega is this one, so I'll just plug in the values on 500. This is 1 by 1000, which is minus 1 into 10 to the power minus 3, that is minus 1 millicoulomb. This much of coulomb. So obviously this is not the, this is actually the current at the magnitude of maximum charge capacitor is not this one, and 1 millicoulomb is not the maximum charge here. The maximum charge is from here to here. So let us find the maximum charge. But this is the charge that is on the capacitor at that time, that you have to remember. And for maximum charge, we do one thing: Q equals to I naught over omega sine omega t. That factor is there, and we to this from 0 to pi over 2 omega, because we know that up to that time only it is maximum, and that we have to find out I naught by omega. And this I already calculated, putting that value sine of omega and pi over 2 omega, and that is 0. And this is sine 91, so it is I naught over omega, which is 1 ampere divided by 500, so it is into 2, so it is 2 millicoulomb, and it's positive. So maximum charge is 2 millicoulomb. So what is the maximum or maximum charge before this? So before this, the maximum charge is 2 millicoulomb, not 1 millicoulomb. So it is actually 2 into 10 raised to minus 3 coulomb. So therefore, this option is not right. Now moving to the second option, the current in the left part of the circuit just before T is clockwise. No, it is anti-clockwise. You can see here, this is anti-clockwise, the current is anti-clockwise. So this option is wrong. Now move to the third part of the question, that is immediately after T is A is connected to D, the current in R is 10 ampere. So let us draw the second diagram. The second part of the question says that immediately after, that is this is a capacitor, and this is a capacitor, and we have a battery which is positive this side and negative here. So this is 50 volt, and this is positive, this is negative, this is higher potential, lower potential, and you have a resistor over here which is 10 ohm, and this is 20 microfarad capacitor. This is the resistance, In this situation, this is the D point and it is connected to that, and what will happen? The question is immediately after A is connected to D, the current in R is 10 ampere. So to find what is the current in this branch. To find the current, let us first see what was the situation. This was negatively charged and this was positively charged, and there was 1 millicoulomb. So it is minus of 10 raised to minus 3 coulomb here, and here it is plus of 10 raised to minus 3 coulomb here. Okay, 1 millicoulomb here and 1 millicoulomb there, but positive negative. This is negative and this was positive. But immediately what will happen is that it will have its own potential difference. If what is the potential difference? Because we know that Q is CV, so the V is equal to Q over C, and the Q, the charge is this one, 10 to the power minus 3 divided by C is 20 micro, that is minus 6, which comes out to be, this is 3 over there, and 1000 by 20, this is 1000 divided by 20, so it is 50. So it is 50 volt. So the potential difference across the plates of the capacitor is 50 volt. But this time this is higher, 50 here is higher. So it is 50 here and 0 here. So I'll say this is 50, this is 0. If this is 0, if I make it 0, then I have to make it minus 50, because this is potential difference, this is higher by 50. So the difference here is 100. So the current immediately after the switch is closed, immediate is the potential difference, that is 100 divided by resistance 10, that is therefore it is 10 amps. So this part is correct actually, that just immediately after the switch R is 10, that is correct. And we have to see this one. The charge flown is 2 millicoulomb. Total charge flown from the battery to charge the capacitor is 2 millicoulomb. That we have to check. What was the situation earlier? Immediately this one was the situation. Now what is the new situation here? What is the new situation? The new situation is that if I draw the diagram properly, then I will use this red pen for that. After a very long time, then it says that you allow the current to flow according to this battery for a long time. After a very, very long time, what will happen is that the battery will maintain a potential difference of 50 volt across it, but in opposite sense, this will become plus and this will become minus. So here the potential difference, the situation will be something like this. I'll just do that again. This is after. Okay, let me draw over here. So I'm drawing in the same page so that you can understand, you can see both the diagrams. Okay, let me draw this. This is for this one, and we have a battery over here, 50 volt, and the resistance is there, and immediately very long time the current in the circuit will be 0. There is no use of resistance, but still I am just doing it. This is 50 volt, so I will just say that if this is 50, this will be 0, this will be 0, so I can say this is 50, this is 0, this is 0, this is 50. So what will happen is that this one will be potential difference 50, and the charge will be CV. The charge is C into E, that is 20 minus 6 into V. The potential is 50. So it is 1000, obviously. 1000 is 10 raised to minus 3 coulomb. So this will be 10 raised to minus 3 coulomb. This is plus and this is minus. So earlier it was 10 is to minus 3 here, minus 1 millicoulomb. Here it is plus 1 millicoulomb. So how much is flown from the battery? Because to achieve this, how much charge would have flown from here to make it this one? So minus 1 millicoulomb. Now it is 1 millicoulomb plus. So 2 must have flown. 2 millicoulomb must have flown. So if it is 2 millicoulomb flows, then 1 millicoulomb will be left. So it must be 2 millicoulomb. So therefore, the charge flown, the total charge flown from the battery here is equal to 2 millicoulomb. So therefore, if I see the options, then that option is also correct. That is 2 millicoulomb. This is also correct. So in this situation, we have 2 options correct. That is option number 3 and 4, both are correct. Okay, thank you.